Sir, good morning, sir. We'll start once the chief guest joins us.
Good morning. Yes.
Good morning, sir. Director, sir, good morning.
Good morning. Good morning, everyone.
Good morning, everyone.
We will wait for Professor Siva Umapati to join in.
Morning.
Morning.
Okay. Where are we?
You can ask to change our view on the screen.
Huh?
You can ask to them to put our screen.
No, let them decide that. That's okay.
Okay.
As long as we are.
But they have control on the camera.
That's okay. That's okay.
They can switch.
Okay, so which on? Are we on?
Yes.
Are we online?
Yeah.
Good morning. Can you hear me?
Good morning, sir.
Good
Yeah, we
morning,
can
sir.
hear you, sir.
Good morning, Professor.
Good morning. Good morning.
Hear me.
Yes.
Switch on the lights, huh? Light.
So shall we start, sir? Or
Yeah, please go ahead. Yes, yes. If everybody is there, we can start. Yeah.
sir, director, sir?
Yeah, please go ahead. Please go ahead.
Okay, sir. Yeah. So a very good morning to everyone who have joined with us this morning. Chief guest of today's function, Professor Shiva Umapati, Director ISER Gopal, Dr. K. Raman Effect, Director CSIR SERC and Coordinating Director CMC, Dr. Bharat Kumar, Advisor Management, Dr. J. Rajashankar, Chief Guest, Chief Scientist, Shri K.M. Sridhar, COA CSIR SERC, invitees, colleagues, and friends. A very warm welcome to one of the main science festivals of India, the National Science Day. In 1986, the Government of India has decided to designate February 28 as National Science Day to commemorate Professor C.V. Raman for his legacy and discovery of the Raman Effect. In an effort to popularize the benefits of scientific knowledge and accelerate the pace of development in S&T, this day is celebrated as National Science Day all over India. It is with this zeal we celebrate Science Day every year in our organization with guest lectures from eminent scientists and researchers. This year also we are joined by Professor Umapati, who is Director of ISER Bhopal, for this year's function. To extend a very warm welcome to our chief guest and to everyone who have joined here, I now request our beloved Director to deliver his welcome address. Sir, over to you.
Respected Professor Siva Umapati, eminent scientist of laser spectroscopy and Director of Indian Institute of Science and Science Education and Research, Bhopal, and chief guest of today's function, Dr. Bharat Kumar, Advisor Management, Dr. Rajashankar, Head BKMD, Sri Sridhar, Controller of Administration, colleagues of SERC and CMC, invitees, ladies and gentlemen, a very good morning and a very warm welcome for the National Science Day function, which is being conducted in virtual mode in view of COVID-19 scenario. It is our privilege and honor for the august presence of Professor Siva Umapati in this function. I express our sincere gratitude to Professor Siva Umapati for accepting our invitation and sparing his valuable time to participate in the celebration as chief guest and deliver National Science Day lecture. As you are aware, National Science Day is celebrated in India on 28th February each year, commemorate the discovery of Raman Effect by the great Indian physicist Sir C.V. Raman on 28th February 1928. On that day, Sir C.V. Raman led an experiment with another great Indian physicist, Professor K.S. Krishnan, on the scattering of light when he discovered what is now called Raman Effect. Raman Effect, path-breaking discovery in spectroscopy, refers to the change of wavelength of light when a light ray is deflected by molecules. Sir C.V. Raman found that a fraction of the incident light is scattered when a light beam traverses through a dust-free transparent sample of a chemical compound. While much of the scattered light has the same wavelength, a small part is found to have a different wavelength than the incident light. This feature is known as Raman Effect, named in honor of the brain behind this momentous discovery. For its discovery, Sir C.V. Raman was awarded the Nobel Prize in Physics in 1930. In 1904, he was honored by the Government of India with Bharat Ratna, the highest civilian award of the country.
Kali.
As Dr. Bharati Vidya mentioned, Government of India designated 28th February as National Science Day in 1986. The first National Science Day celebration was held on February 28, 1987. Since then, February 28 is celebrated as a National Science Day throughout the country with great enthusiasm as an annual feature to mark the importance of contributions made by scientists. Every year, National Science Day is celebrated with a particular theme. The theme for National Science Day 2021 is Future of Science, Technology, Innovation, Impact on Education, Skill and Work. To promote the spirit of creativity, innovation and scientific temper, SERC and CMC are celebrating the National Science Day 2021, and we are grateful to Professor Siva Umapati for giving consent to deliver National Science Day lecture on challenges to innovation for the young minds in India, in line with the theme of National Science Day 2021. I once again welcome you all for this function. Thank you very much. Thank you, Professor.
Thank you.
Over to you, Bharati.
Thank you, sir. Yeah, thank you, sir. Thank you so much. As directors are mentioned, fittingly we have with us renowned researcher and academician who inspires young minds every day, Professor Siva Umapati, ISA Director. I now request Dr. J. Rajashankar to formally introduce the chief guest to the audience. Rajashankar, sir.
Yeah, thank you, Bharti. Am I audible?
Yes, sir, you are.
Yes.
Fine. Yeah, thank you. Very good morning to the dignitaries, Professor Siva Umapati, Director of ISER, my other colleagues, the Director, Dr. Raman, my other colleagues. It's a very pleasant day for all of us to listen to Professor Siva Umapati. And I have the pleasure of introducing Professor Siva Umapati to our colleagues, to the audience here. I'll take just 2 minutes. Professor Umapati is currently the Director of Indian Institute of Science, Educational Research at Bhopal, right from 2018 September. And regarding his birth, he was born in Tanjavur on 10th June 1959. And he graduated in chemistry, I think Kongunadu Arts and Science College in Coimbatore, I think. And subsequently joined PhD College of Technology, wherein to get his MSc in Applied Science in 1981. From then on, he moved to New Zealand for his doctoral studies and got a PhD in Physical Chemistry from University of Otago. Subsequently, he got a research fellowship on Science and Education Research Board, I think. He did his postgraduate studies at Rutherford Appleton Laboratory and University of York. And after finishing his postgraduate studies for postdoctoral, he came to India, and naturally he went to Bangalore and joined Indian Institute of Science, Bangalore. And he's a professor there in the Indian Institute of Science, the Department of Instrumentation and Applied Physics, and the chair of Department of Inorganic and Physical Chemistry. There he heads the laser spectroscopy group at the Department of Inorganic and Physical Chemistry, and wherein he hosts a large number of doctoral and postdoctoral scholars. And during his serving at IISc Bangalore, he has also served as a visiting faculty or a fellow of various institutions, renowned institutions such as Kangawa Academy of Science and Technology, University of Groningen Institute of Molecular Science, University of Tokyo, Imperial College of Science and Technology, goes on, University of Nottingham, and so on and so on. I think he had the pleasure of joining, and I mean, we have a very eminent personality here with a lot of experience. And about his work experience, I think he centered around laser spectroscopy. And he has carried out extensive work on molecular dynamics using Raman spectroscopy. And his group also was mastered in spectroscopic techniques like infrared and so the involved in examination of molecular structure of cells and tissues. I think with this experience, about his always naturally, he would have got a lot of credentials, a lot of awards and recognition. I list a few of them just for recognition. Say, I think Professor received the Professor J.C. Bose National Fellowship from the Department of Science and Technology, and in the year 2010 to 2020, a Young Investigator Award for the ICORS conference at the University of South Carolina in 1989, Swarna Jayanti Fellowship in 2020. He's a Fellow of Royal Society of Chemistry, it's a great recognition, and he's an elected Fellow of Indian Academy of Sciences in 2003. And he's also a recipient of Sir C.V. Raman Young Scientist Award of the Government of Karnataka in 2003, and our own CSIR Swanti Swarup Bhatnagar Award, one of the highest Indian Science Awards. He got it in 2004 in recognition of his work. Subsequently got the Bronze Fellowship from Chemistry Royal Society, and he's also a recipient of Raman Mishiguma Award of Indian-Japan Science Promotion Council. Many more are there. Of course, I have to limit now to give the space to Professor Umapati. And somehow I have been saying all our eminent lectures on Science Day are all connected with Bangalore. And naturally, Professor Umapati also is associated in Bangalore. Thank you, sir. And once again, I thank you for accepting our request. I request you to deliver your lecture on challenges to innovation for the young minds in India. Over to you, sir.
Thank you very much. I'm very pleased to be here on the Science Day lecture. And first, I want to thank the director, CSIR, CRC Laboratory, and also Dr. Rajshekhar for the introduction. So I've been giving lectures on science topics like laser spectroscopy, but I felt that, it's more important that in India now, the future of India depends on innovation, and it's all going to depend on the knowledge society. Our economy has been running on services like computer science, where we do concentrate on service industries. But it's time that we started developing technologies, and the country depends on technology to the world, not providing service to the world. And that's what the Prime Minister is interested in. That's where the manufacturing, make in India, made in India, all these aspects are coming in. Along with that, one way to empower the country in terms of technology is to improve innovation. Now, if you want to improve innovation, if you look at 50% of people in India, they are below 35. So these are the people who are going to contribute to the future of India. They are the ones who have to come up with the innovation and technology that is going to serve the world, not necessarily only in India. So I thought I'll talk about, I've given these lectures in IISc to PhD students and also to young faculty in various places, of course, including all ICERs. So I thought I should share that experience with all of you. The challenges today for young people is very complex because innovation requires curiosity, the ability to observe what is around you, and based on those curiosity and observation, you frame the right question to find, discover, or invent. And once you frame the question, then it becomes much more complex to develop methods to conduct an experiment, conduct the right experiments under the right environment, and therefore you discover. Now, I normally say that in order to do, you need to have 7 habits of being an innovator. You must have a good understanding of philosophy of research. When you say philosophy, the idea is that there is a difference between innovating and discovering something from value adding something. That's a big confusion in Indian mind and probably true or even around the world. If somebody has done an experiment with a material A and changing the material to B without a good justification, some people believe that's innovation. That is not innovation. An example of innovation is that 20 years ago, in the early 90s or late 80s, when we were students and we were starting our career, there was no mobile phone. When you try to make a phone call to somebody, even across the country or abroad, you may have to spend maybe half an hour to get connected to someone. And if somebody had come to my office and told me at the time, no, don't worry, in another 10 years, I'll give you a small box, which is slightly bigger than a matchbox. You can dial the number and speak to them instantaneously anywhere in the world. I would not have believed it. Nobody would believe it. The people will say, what, are you joking? Is it possible? Now that's the discovery of mobile phone. It's a disruptive technology. It's a technology that nobody even imagined that has transformed our lives into extremely productive and useful. And so that kind of disruption. Now, that kind of disruption doesn't come by saying, I want to innovate. It comes by learning what are the lacunas in the existing system, what are the possible technologies available, possible scientific knowledge available today. How can I then apply this knowledge to develop a new technology? That is what's the philosophy of research. Philosophy of research is about understanding what it takes to become a good innovator. And young people have difficulty in perceiving such differences. That's one thing. The other thing is that the second habit that an innovator must have is a value system and a personality. The value system requires clear understanding of not trying to impress people, trying to do what you're trying to do in an honest, sincere way. You need to have a personality to be very strong, to say, I'm trying to do my best, I will do my best. In a very clear understanding that I do know this, but I don't know that. Some young people begin to believe that if you have a degree, you become an expert. Some people think that if you're a teacher, you should know everything. I always tell my students, first thing you need to learn if you want to do a PhD is to say, I don't know something. Because more you learn, more you realize that you know very little about the world. So that kind of thought process has to come into individuals to be humble and humane in trying to understand what you're trying to do. Now that allows you, when you realize that you are not, you don't know something, you will make more effort to learn and understand something. So that is the other part of it. The next part is perseverance. In most innovations, you never get what you want in your first attempt. What you end up getting is some failure, and you must be prepared to face that failure and try to then work out why I failed and try to find out the bottom line of what are the possible reasons for failure, and then how do I change it. That's the next step. In the process, you learn there are happinesses and pain, because you work so hard for so many hours, so many days, and sometimes so many months and years, and you don't get results of top class, world class innovation. So you get worried. It depresses you, and so these young people sometimes give up, and that is where they have to come and say, I know, because every time I fail, I'm learning something. Therefore, in the process of failing, you have actually closed the doors of problems. So you come up to the reach point of a success. So discovering something. And in today's world, what is happening also, since the competition is so severe, to share your ideas, to share your results, you must also have an effective communication methodology, whether it is by speaking or by presentation. And that is something that we are lacking. It's basically soft skills training that is required for the young people. So in ISER Bhopal, for example, I insist that the final year students must undergo soft skills training, which includes, how to present yourself or present your research or present your personality to an interview committee, or how to write about yourself in a positive way, and all these. So the other thing that I always say is that in an Indian context, we have a confusion between what is correct in our culture and what is required in an innovative system. In our culture, we believe in extremely obedient respect in the system to the seniors, whether it is your parent or whether it's your uncle or aunt, or whether it's your teacher or your superior in your laboratory. Now, the problem is that we assume, or we are taught, or the children are taught, that if you're obedient, you can't talk back to somebody. Now, the problem is, talking back to somebody does not mean you can't disagree with them. The creativity comes in when a student expresses disagreement with the teacher, either because he hasn't understood it, or because he has a fantastic idea better than what you have suggested. So in either way, sometimes the teachers never allow them to disagree with them, or the students are afraid of disagreement. So I always tell my students, there are ways to disagree. You don't have to be rude in disagreements, because our culture says you need to be obedient. But you can disagree very politely, saying, I agree with you, sir, but can I say there is an alternate way to find the same solution? And if the teacher is generous enough, they will accept it. So that culture, for example, has to change. We must learn to listen to youngsters who are willing to disagree, and therefore the obedience is not absolute in terms of respect and disagreement. Similarly, consciousness. Sometimes this kind of somebody who is superior tells you to do something which is wrong. You probably think that, oh my God, he is more experienced, so he may be right. So I have to do it even if it is wrong. That, for example, is a problem with our system, where our young people have to learn to say, why am I doing this? If I say go and do an experiment, they should not leave the room without understanding why they are going to do the experiment. And that is something that all of us have to take responsibility in converting the idea into a proper discussion, and then convince the student that there is a need to do this. So the young people have to also ask the question, am I doing this because my boss asked me to do this? Or am I doing this because I think this is a good way to do? That is the other other reason, our cultural reason, why we many a times we actually go in the wrong direction. We may be very bright, but we are so obedient and respectful to the superiors, and we lose the direction. Also at home, the other problem that we always experience is ranking. I remember I used to tell my people that, there are certain parents, or many of the parents they ask you, what is your mark today in your class? You say, I got 80%. Then they'll say, what about your friend who is living opposite side? Then he'll say, he got 85. Then he say, oh, so when he can get 85, why can't he get 85? So now the student think his target is only beating the person across the road, or your neighbor, or your relative. Now, next time when he gets 85 and comes home and says, I got 85, next question is, what did your friend get? And if that person got 87, then you argue saying, what is the point? When he can get 87, why are you getting 85? So we are spending a lot of our time unnecessarily in talking about numbers and ranks in a class, while knowledge is actually absolutely not considered into the equation of innovation. So I always tell my students and others, I don't care what your rank in your class is. I do care what is actually you have learned in the classroom. Because at the end of the day, whether you're doing 10th standard or 12th standard or BS or MS or whatever, as long as you're in the top 5% or 10% of the class, as long as you understand the subject very well, you will definitely reach a stage where your understanding would actually help you in your pursuit of profession, rather than the rank in the class. Because after masters, nobody really worries in your biodata what rank you had in your class. So that is something that parents don't understand, and that stifles young people, very bright people, trying to score marks by mugging up, by trying to answer questions of the last 10 years of examination, rather than trying to understand what is it they are studying. And that stifles their innovation. Capacity to question, capacity to have curiosity is missing. The other thing that they do in a classroom, we always teach them, we never tell them to have a competitive edge which are on a friendship basis. There is, because of the intense competition in our culture, because for every job there is thousands of applications, we end up being jealous of other people, become cunning about others. Now, when you become jealous and cunning, your intellectual capacity comes down by 50%, because you are really not putting in all your effort to actually do the innovation. So what you do is you spend most of your time doing the politicking and spend less time. And this actually happens from school days to college days to profession. If you look at the Western world, maybe the competition is very less, but they've always been told, even when they are in school kids, that you must have a positive, friendly competition. You should never be jealous and competitive of anybody, because the jealousy and competitiveness and cunningness kills your mind's quality in sharpness of your thinking process. This also leads to another problem, which actually in modern world is extremely important, the ability to work in a team. Now, if you become extremely selfish right from your school days, and young people are taught to be successful alone, now what happens is when they have to work in a team to solve a problem, in today's world, 30 years ago or 20 years ago, you could have been an expert in particle physics and sit in your office and do your work, and it doesn't matter, but you will still be successful, world will recognize your work. But 99% of work today is interdisciplinary. Whether you take biology, physics, chemistry, engineering, civil engineering, mechanical engineering, electronic communication engineering, everywhere is interdisciplinary research. And if you are not able to have an open conversation with a colleague who is equally an expert on another subject, or equally an expert in your own subject, but in different part of your own subject, you will never be able to make an impact in the world. That is something that people have to worry about and needs to understand. There's one more thing that also unnecessarily feeds into our interference with our innovation is ability to interact with people. This is the difference between intellectual quotient versus emotional quotient. Now, intellectual quotient you may have as an individual. Emotional quotient is about teamwork, about perceiving others' culture, perceiving others' ability and interaction, perceiving others' opinions in a very positive way, and also trying to work in a team, understanding why somebody is upset. The emotional ability to handle a team of people, somebody who is extremely aggressive, somebody who is extremely passive, whether it is in your football team or in your work environment. That's something that we never teach our children. The young people never understand that, okay, today he is angry, so I will leave him alone. Maybe I'll speak to him tomorrow. For some reason, we end up arguing and breaking the relationship. This is something that is not normal. This also comes from competitiveness, lack of respect for colleagues. If somebody is not good on something, I'm sure they'll be good on something else. And that respect we must have with everybody. And that is another reason why innovation is stifled. Because if you lose respect to your colleagues with whom you are working, and you are not able to understand the other person emotionally as well as intellectually, then the ability to work together to develop a new technology then becomes a big issue. And that is something that is always worrying in terms of developing personality. The other thing that we have not understood is, how do you learn to maintain a relationship in a professional environment? When you have a close friend, we have ability to have tolerance for that friend because that person is very close, whether it is your brother or an extremely close friend from school. Although they may have their own issues of uncomfortable behavior, we tend to accept that, saying, it's okay, it's my friend, I can tolerate it. But then when you don't have somebody so close, or if you think somebody is competitive, the tolerance limit for that person is very low, which means even if they make a mild mistake, we tend to get angry. That kind of self-realization to appreciate in a team, how do you work with somebody even if you don't like them, is something that we have never taught. That's something that we have to work on and help people in this world. Now, the other thing is a critical analysis of the data that you get. When you do an experiment, you have to understand, am I fair in my analysis? Very famous example is one such example of analysis. A very ambitious young person told a professor who is in biology, behavioral biology, saying, I want to do an experiment, please give me an experiment. So the professor gave him an experiment of a frog, saying, can you find out what is the effect of disability on this frog? And this guy, so basically what he did was he took the frog and tapped the table. The frog jumped 3 meters. Then he said, okay, I will cut one leg and then tap the table and say jump. It jumped for 2 meters. Then he cut the third one, 1 meter, the fourth one, it didn't jump. So he immediately went to the professor saying, I think I found something extremely important. We are going to get a Nobel Prize. He said, look, what have we done? Explain to me. He said, no, sir, I found something very important. He said, what did you find? The student said, when the frogs, all the 4 legs are cut, it becomes deaf. It doesn't listen. It can't listen. So it's a poor understanding of the experiment. And it's poorly analyzed data that you received. That's because lack of ability to think about it rather than thinking about success. So if success becomes more important than the analysis, then your result will always be wrong. So it's very important to think, make sure that your analysis is correct, and then make sure that your success is followed by the analysis, but not before. The other thing that's actually done in India, very common for everything and always, is people say publish. And CSIR does it as well, unfortunately. But I tell Shekhar Mande that he agrees with me that publishing is not everything at the end of the world. Quality publishing is the important. So that's something now is transforming in India. Until about 5 years ago, numbers mattered. Now I think quality is beginning to be mattered, and that is something that we should also expect. And finally, what I would like to say is a scientist is equivalent to a CEO. That's something that many people don't understand. If you are independently heading a research program, whether you're doing it on your own or whether you're working in a team, and if you're heading a team, you are equivalent to a CEO, because a CEO does the following in a company. He does human resource management, which means how do you manage people who are working under you to provide efficient service or efficient delivery of projects. And then details of project, what is going to be a successful project, what is a timeline of project, so that means project management. And planning, because if this project finishes in 2 years or 3 years, what will I do 3 years from now on? And you have to pay the salaries of your employees. So you must have your product line ready. So you need to have future planning. In planning alone would not be enough. You need to have finance management. So you need to bring in finances and make sure that profit is made. Now, when you have finance and planning and projects, you have administration. So you have people or purchase officers or other offices. Now you can now do all of it, but if you don't do marketing, you will never get any finance. So even if you do successful research, you need to share it with the rest of the world, either by publishing in top journals or by sharing with the industry in terms of technology developed. So a typical scientist goes through human resource management, project management, planning management, finance management, administration, and marketing management. So this is not so straightforward understood. The depth and breadth of running a research program is extremely complex these days. And finally, what I would like to say is that the communication part, again, when you are sitting in a meeting or sitting in a seminar, we learn to communicate in asking a disagreeable question, or even questions during seminar is something that we have not been exposed to. Either we extremely keep quiet or extremely get angry, upset about something that we disagree on. And when you speak, when somebody asks a question, even if it is offensive, you need to have a composure to answer the question peacefully and quietly. And that's something that is very important to actually to get funding for your future program or successfully moving the thing. So finally, what I would like to say is that innovation leads to success, but the success can be defined in many ways. For many people, success can be just contentment, satisfaction of discovering something that is useful to other people. Therefore, you find happiness. For some people, recognitions, awards and recognitions is the success. Now, for me, I think if you enjoy being creative, innovative, that actually changes the way people think, changes the way that people like to behave, and culture, social value system changes, social lifestyle changes because of that. And that will be a fantastic success, which will then followed by recognitions anyway. I mean, you don't have to ask for it. If your innovation is good, recognition will naturally follow. And there is always a negativity in an environment. You know, some people get awards, some people don't. And that, I think, will change with time. I think we have gone through that in the early days. Now I can see that there is a lot of discussion about values in decision-making, and the justification in decision-making is becoming more and more important at all levels, right from the top to the bottom. So I think I can only think of a positive future, but it's important to protect the youngsters and train the youngsters in the right direction. And Science Day is one way to communicate that message to all of them. So with this, I will leave it for questions to come from the audience. So thank you very much.
Thank you, sir. I now request if any one of you have any questions to the chief guest to please raise your hand virtually, and please feel free to ask any questions. I see no hands raising. Probably the lecture has to people more about asking questions without any inhibition. Sorry, sir, I'm not able to hear you, sir. I think you're muted.
Sir, you are muted.
Yeah.
You are muted, sir.
Yeah, right. Okay. So, I'm saying this is one such things, right? So you should not worry about what others think about what question am I going to ask, which is one of our problems in any society. And somehow we feel that, it may not be good to ask or something. You should feel free because it's a intellectual process of discussion of what is right in the world today in terms of research. So what I'm saying is my experience with my students and what I see in India and around the world. So that's what I've shared. Yeah.
Certainly, sir. So thank you so much for this stimulating lecture. Your lecture beautifully echoed every necessary points in the spectrum for turning good ideas and imaginations to true innovation. As a young scientist myself in this organization, your lecture highlighted how beautifully, building up scientific temperament and innovative thinking and propagation of healthy scientific culture among, young STEM enthusiasts are critically important, especially in today's environment. Thank you from the bottom of my heart, sir. And now I request Shri K.M. Sridhar to deliver a formal vote of thanks for today's function.
Thank you, Dr. Bharti Priya. It is indeed my great pleasure to propose the vote of thanks. First of all, I extended my warm vote of thanks for and behalf of Director and Coordinating Director, Additional Charge of CMC, Dr. Raman Effect, and the staff members of CSIR, SERC, and CSIR CMC, to Professor Siva Umapati, Director, ISERC Bhopal, for having accepted our invitation and gracefully honoring our occasion and delivering an excellent lecture on challenges to innovation for young minds in India. It is also a great pleasure to thank Professor Siva Umapati on a personal side, because I have been a student of his father, Professor Siva Subramaniam Matanamlai.
I see. Oh, I didn't know that.
Continuing with a great exponential rise in achievements. Sir, personally, I thank you for having accepted the invitation from our side, sir. And also, it is pertinent to offer thanks for highlighting how success encourages high social values, and success is equal to recognition, how different people perceive success. It's a wonderful thing. And the frog example, which he said, how things are perceived, is a really nice thing, sir. We thank you. We extend our heartfelt thanks to your for sparing your wonderful and time with us despite your tight schedule, sir. I also thank Director CRC and Additional Director CMC for having arranged the Science Day lecture for the benefit of all the scientific community. We, the support staff, also understand how our role is important, as Professor Siva Umapati highlighted the system. To get a complete system for success is equal to innovation is equal to success, success is equal to social value. This is the equation he built today. Thank you, sir. And I thank all the infrastructure sections and all the staff members who attended this function and made it as a success. Thank you very much.
Thank you. Thank you for the opportunity. Thank you.
Thank you, sir. I once again thank every one of you who have joined here today for today's function. I close this function with a saying which is close to my heart. What is now proved was only imagined one day. So fly your imaginations high, and with this thought, we close today's function. Thank you so much, sir, for joining, and thank you every one of you for joining. Stay safe and keep yourself healthy and stay safe. Thank you. Thank you so much.
Thank you.
Thank you, Professor. Thank you.
Thank you. Thank you.
Thank you, Professor. Thank you.
Thank you. Thank you.